when you are working on very complex products, one of the main steps developers and engineering groups can take is automating everything. I mean, that's probably, along with reducing the batch size, so making the things that you're delivering smaller so that you can do more of them and you're iterating on them, right? One of the key things that enable your engineering team to have the confidence that they can continuously deploy to production those small things is to automate everything. You should have automated testing. You should have automated deployment. You should have as much as you can automated validation. There are automated validations you can do, especially if you're collecting telemetry in your product. A great example of that was the Azure DevOps team when they first started deploying their cloud version of the product. They didn't have, they'd been used to doing 2 yearly deliveries, and suddenly they were doing 3 week deliveries, and they had technical debt. They had poor quality code. They had big gnarly chunks that were very difficult to edit, and they had automation that took a very long time to run. So there was kind of two big focuses, big engineering pushes that they made in that team that I think had the biggest impact. So me observing their improvements. And the first one was that they reduced as much as possible that cycle time, right? They wanted to time to learn. They wanted to reduce that time to learn as much as possible. And time to learn is all the way from I come up with an idea for a feature. It gets all the way through being built, or some of it being built, being deployed to production, or some of it being deployed to production, and collecting telemetry and then feeding that back all the way around to the next loop. That's time to learn all the way around the loop. So figuring out what the biggest time suck is in that space and tackle that. So for the Azure DevOps team, they found a number of things. One of those things was their testing infrastructure. Their testing infrastructure was, for one of a better expression, terrible. It took, as I understand, about 48 hours to find out for developers if they made a code change, whether it was successful. Their time to self-test, right, their ability to test for themselves was incredibly long. That's 48 hours to 72 hours. And the time to run the regression suite was even longer than that. It was perhaps a week to get that done because they had long-running regression tests. And one of the biggest focuses, biggest pushes they had was on converting all of those long-running functional tests into short code tests, right? So they were top-heavy on their largest number of tests were these long-running functional tests. Their smallest number of tests was unit tests, and they flipped that pyramid over. It took them 4 years, because remember, they've been working on this product for 6 to 8 years in a waterfall way. And they built this massive test infrastructure. So it took them 4 years of doing a little bit at a time, paying back that technical debt to get to the point where they'd flipped that pyramid over. And in fact, they just removed whole layers of that pyramid, and they ended up with all of these fast running unit tests. So instead of 80,000 long running automated tests, they had 80,000 short tests. And they moved that number from 48 hours to find out if a developer had done something wrong to 3.5 minutes. They could run the whole test suite in 3.5 minutes on their local machine. They could stand up via command line calls any parts of the system that they needed in order to be able to do functional tests locally on their machine. That was one of the other changes that they made. How do we enable that so that developers can just run a command and it sets up the bits they need to test the stuff that they're working on locally, so that they can have a copy of the system running locally and walk through it. And they build all of that functionality. It took them a long time to get there, but that investment helped improve their confidence in their ability, not just as individuals, but as a group, to be able to deploy and build features in the product, and improved the confidence of their customers. Right, their customers had greater confidence that this is a good product, it's a solid product. Yes, we've seen things go wrong, but when things go wrong, they own up to them, they fix them, they move forward, they don't make that mistake again. So that building because it's okay to make mistakes. If you've got a customer that you make a mistake and they throw a tantrum, they throw their toys out the pram, it's because they're used to working with vendors that they have low confidence in, and they have low confidence in you fixing it. So they believe that they have to throw that tantrum in order for you to fix that thing. So if you need to build their confidence in you and in your product, and then they'll stop doing that. They'll accept, oh, something went wrong, you messed up, but we know you're going to fix it. We know you're going to do a good job, and we know that you're not going to do it again, right? Or it's unlikely that you'll do it again. That's confidence. And when you're working in big complex systems like Azure DevOps or other types of systems that you have, you need that level of confidence, not just at the whole product level, but at every individual team level. I working on a team need to have confidence that if I'm using capabilities delivered by another team, that they're going to be solid, that they're going to work, that they're going to meet that quality bar that I need in order to do my work. And I'm not going to be your crutch, right, to enable functionality. So this is really, really important to have that underlying attention to detail, attention to quality, shorten those feedback loops, build up that automation, automate everything. There should be no manual tests. One of my favorite examples of that is the Azure DevOps team. They had poor telemetry in their product when they first moved to this cloud environment, and they were deploying through regions. So they would deploy to a region, and then they would check to see that everything was working properly. They would check to see whether they'd adversely affected users. They had to do this all manually, and then they would deploy to the next region. And one of the developers, an intern, for fun, developed something they called the Twitter sentiment bot. So this was a little bot that trolled Twitter for negative comments about your product. So what they would do is they would do a deployment to a particular region, and then the Twitter sentiment bot would monitor Twitter for a couple of hours to see whether people started, the level of negativity about your product increased in any way. You're always going to have a baseline of people that are unhappy with stuff, right? So if it increased in a certain way, then they would automatically stop the deployment and flag that there's something that needs to be looked at. That's a crutch, right? That's a way to automate something that isn't automatable because of the way you built your system. They eventually didn't need that bot anymore because they had those full automations built into the system. But you need crutches while you get there to be able to push those boundaries and keep pushing for continuous delivery, keep pushing to do things faster, keep pushing to improve your code and improve your quality and improve your engagement with your customers, and you'll get there eventually.